Alrighty, Chapter 18, Air Pressure and Wind. Air pressure is the pressure exerted by the weight of air above. This has to do with our gravitational force. At sea level, it's about 14.7 pounds per square inch. Air pressure is in all directions. That's why we cannot feel it. It balances itself out. For example, if you think of an aquarium on top of a desk, that pressure is focused at the top. With air pressure, you can think of instead the desk inside the aquarium. All the water is pushing on all sides of it. Alrighty, wind. Wind is caused by horizontal differences in air pressure. It flows from areas of high pressure to areas with low pressure. For example, if you open a sealed container, you can tell that the pressure is trying to escape and balance out, so it rushes towards outside. Solar radiation provides all of the energy for this wind. And wind is just nature trying to balance everything out. So 3 main forces create our wind. First, we have the pressure gradient force. This is adjusted to sea level so that we can accurately compare pressure in different areas. If we didn't do that, then it would just seem like certain areas would always have high pressure or low pressure. Isobars are used to show areas of equal pressure on weather maps. So you can see it groups them together. And remember that wind flows from high pressure to low pressure. Alright, Coriolis effect. This has to do with the rotation of the Earth. So instead of the wind flowing perpendicular, it's instead going to go to the right or left depending on which hemisphere you're in. So on weather maps, we can see that it's separated by isobars for similar pressure. And once we add the wind speed symbols in there, it shows that the Coriolis effect diverts the wind a little bit to the right. The third force is friction on the Earth's surface. So normally, wind is just going to flow parallel to the isobars, but near the surface we have friction that complicates that airflow. What would the isobars look like for this pressure system? Okay, so we have a low pressure system in the center with isobars closely packed together, and then those are going to increasingly space out as you go further away. Remember that all wind is formed for the same reason, pressure differences that arise because of temperature differences. Okay, so we want to measure that pressure in wind. First, we have a mercury barometer that contains liquid mercury. It's pushed up or down by air pressure and is measured in inches of mercury. It's pretty unrealistic though if you want to move it around anywhere or be safe in any way, so we also have the aneroid barometers. So these are more portable. The only thing you have to remember is that weather is going to be predicted using change in pressure rather than the current pressure. So for measuring wind, we have 2 devices. We have a wind vane that's going to tell us the direction, and we also have a cup anemometer, and that's going to tell us the speed of the wind. Okay, this is important to us because weather, we deal with it every day. In low pressure systems, we tend to have more cloudy conditions and precipitation. In high pressure systems, we have clear skies and fair weather. Okay, let's talk about some cyclones. So cyclones are probably just what you think about. It's a center of low pressure that blows inward and clockwise. On the other hand, we have anticyclones, and those are centers of high pressure that blow outwards and counterclockwise. Remember that all this wind is, for the same reason, pressure differences that arise because of temperature differences. Alright, locally, we have different types of situations that will happen. This one's for us in Florida. Cooler air that's above the water is going to move towards the warmer air on land. This happens in the afternoon. And at night, the reverse is going to happen because the land cools quicker than the water. This is why it's cooler for us to live near the water than it is to live inland. In mountains and valleys, we have something else happening. The air inside the valley heats up and is going to rise outwards. Then the cool air is going to come back inside and provide some cooler air for them. Right, we also have the Santa Ana. This is in the other coast in California. High pressure is moving outwards, which is not good for wildfires. It fans them and helps them spread more quickly. Okay, you might have also heard of El Nino. So this is the gradual warming of the waters in the eastern Pacific. It happens in irregular intervals of 2 to 7 years and can last from 9 months to 2 years. This impacts the weather and economy of a lot of countries, such as Peru, Chile, and Australia. Alright, so in summary, I want you to take a second to look at these two maps and see what you can find out. When I'm looking at it, I can tell that the areas of lower pressure tend to be where there's more precipitation. Like if you look over Africa, the lower part, or South America. But on the reverse side, if you look at northern Africa, you can see that there's the desert there, and that's also a higher pressure system, so less precipitation. Earth's rotation has a lot to do with this, like we talked about earlier. So if we had an Earth that was not rotating, there would be unequal heating on the Earth. But our Earth does rotate, and because of that, we have different cells that form where our air can circulate. Okay, so precipitation, like I mentioned a little bit earlier, where you see the red dots in the center, we have some low pressure happening, and that's where there's more precipitation. Then that goes towards the pressure on the area where you can see the desert, so there's less precipitation over there. So of course our air is going to flow back towards the center, and then the red arrows adjust for the Coriolis effect. Okay, so let's see if you learned anything. Oops. Okay, I want you to stop the video here or just pause it. Discuss with the people sitting around you what you have learned. You can use some ideas listed on the page here. Luckily, this is a video, so I know I talk really fast. You can go back and rewatch any parts that you might have missed.